Hello everyone, welcome to another while loops video. Today we're going to talk about using numbers with while loops. So we're going to be doing some number analysis and generating a range or set of numbers with our while loop, and also manipulating some outer variables. Before we begin, I wanted to recall a very key technique or an operator that we can use with while loops called assignment operator. Remember that with assignment operators, what it does is we get to combine both the assignment operation and a mathematical arithmetic operation to update a variable. So for example, if I were to talk about the plus equal sign, I have variable A and I'm going to add the value of variable B and update that result back onto the value of A. So in this example, I have variable 1, variable 2 of 42 and 13. If I were to subtract 13 from 42, I would get 29. And variable 1 would be updated to that value by doing the minus equal operation. So this is very important because in a while loop, at every iteration, we are most often manipulating or updating a variable that we declared outside of while loop, which helps us to make our Boolean condition become false so that we can exit our loop. So let's look at a simple program. What we're going to do is look at numbers from 0 to 100. And based on changing some of our conditions and variables in this example, we will be able to analyze a whole bunch of numbers in certain ranges. So starting at 0, we're going to say while our number is less than or equal to 100, I'm going to print that value. Now, if I wrote the code just as it is without this assignment operator here, it would continuously print 0. Because num isn't changing. We're not updating this variable num, and this Boolean condition will always be true because 0 is always less than or equal to 100. Therefore, after I output that number, I'm going to increase that by 1 at every iteration. So that 0 becomes then 1, then 2, then 3. It continuously increases itself at every iteration until our condition becomes false. So we'll be able to print all the numbers from 0 to 100 inclusive. Now, it will include 100 because the while loop executes when the number is equal to 100. So it will print 100, increase the number up to 101. That will make our while loop statement false, then exit. If I wanted to go backwards, I can simply reverse what we did in the previous example. I can start at 100. So we can say while our num is greater than 0 because we're going from 100 to 1. And we can print that number and then take away 1 at every iteration until our num is not greater than 0 anymore. As soon as this condition becomes false, we exit our while. So let's look at a different simplistic program. We are now able to generate numbers in a range. So using that feature, what I'm going to do is add on a little complexity. We're going to display that one number is even and the other number is odd, and continuously loop through the range that we were given from values of A and B. So in this example, A was 1, B was 4. So in that range, 1 is odd, 2 is even, 3 is odd, 4 is. So in that range, we're going to determine all the odd numbers. So to set up, I need 4 variables, input 1 and input 2. They are integers, and we can put some little messages to grab those values. I need to know what values to start at, and I want that to be the smaller value. And to end, I want the value for the end variable to be the bigger value, so we're going to take advantage of the min and max functions here. After that, we're going to say, well, while our start variable is less than or equal to the end variable, and I'm going to put also start plus equal 1. This way, A, for sure, I'm ending this loop when start becomes greater than end. And also, we are going to start at this variable value start and go all the way up towards end. So then we're going to write our conditional statements here. We're going to say if start modulus 2 is equal to 0, that means that number is even. So I'm going to output start is even. Else, if it wasn't 0, then it must be an odd number. So I'm going to output the number and output string of odd. And this is going to continuously go until we keep on manipulating the start variable to become greater than the end variable. That way we get to look at all the numbers starting at start, ending at end. So my challenge for you would be the Collatz conjecture. So this is a conjecture that it's explained as so. So we can start with any positive integer of n. Then each term is obtained from the previous term as follows. If the previous term is even, the next term is 1/2 of that. If the previous term is odd, the next term is 3 times that plus 1. And the conjecture was stated that no matter what the value of n is, we will always reach 1 to terminate this pattern. So if we were to look at some examples, so n of 12 starts at 12, it goes 12, 6, 3, 10, 5, 16, 8, 4, 2, 1, where it was following the rules of if even, divide by 2, if it's odd, multiply by 3, and add 1. And here, I've also given you other examples of N19 and N27. I recommend that you pause the video here just to see if it's following the pattern or not. What we're going to do is, well, if the user gives us an input of n for any numbers greater than 1, we're going to determine the numbers determine all the numbers in that Collatz sequence. So if we were to start at 6, we'll output 6, 3, 10, 5, 16, 8, 4, 2, then 1. Of course, this would go vertical. It's just that on this slide set, I ran out of space. And what I want to do is utilize everything we learned in this video so far, try to program the code. Thank you for watching. Stay classy.